Hey you guys, today we're going to be talking about topic 1.3. It's called the rates of change in linear and quadratic functions. To start off, for a linear function, the average rate of change over any length input value interval is constant. Also, the rate of change of the average rate of change is 0. So this might be a little confusing because you see the word rate of change over and over again. So let's break it down. So again, for any linear function, your average rate of change is going to be constant. When you hear the word constant, I want you to think of those numbers being the exact same. So they're not going to change. That's different than for the rate of change of the rate of change, which is going to be 0. So just to give you an example of what a linear function could be, let's say I have a table that has some x and y values. Okay, let's say this is just 1, 2, 3, 4, 5, just to keep it easy. So all the x values are increasing by 1. And then let's say we got 10, 15, 20, 25, and 30. Okay, now to find the average rate of change, you have to find the change in your y value. So to find the change in the y values, I know that I'm going to have to add 5 plus 5 plus 5 plus 5. That's the pattern, right? You're always adding 5. The first time that you do this process, that's going to give you your average rate of change. And if you can see, the average rate of change is constant because all the numbers are the same, they're all 5. If you repeat this process and you do it a second time, to get from 5 to 5, you would add 0, and add 0. Okay? This second time is going to be your rate of change of your average rate of change. Okay, so your average rate of change is the first time, and the rate of change of the average rate of change is the second time that you repeat the process. And for a linear function, the second time when you find the rate of change of the average rate of change, all of your numbers will be 0. Okay, we often think of this as the slope of the line. A few lessons ago, we talked about the formula for the average rate of change. As a refresher, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We can also say it's the change in the change in y over the change in x. Okay, and then I also inserted a picture of what a linear function could look like, so we know it's just a straight line with either a positive slope or a negative slope. So it can go up like that, or it could also go down like this. Let's move on to quadratic functions. For any quadratic function, the average rate of change over any length input value interval is not constant. Also, the rate of change of the average rate of change is constant. Now, this one has a little typo, so I want you to erase the word linear there, and I want you to add it to the top part. Okay, so your average rate of change for quadratic functions is not constant, but it is linear. And your rate of change of your rate of change is constant. So that means that the first time you do the process, you're not going to get the same number, but the second time you do the process, you are going to get the same number. Now, sometimes they'll phrase the questions like this, so I'm just going to write this here just in case. They might say, for quadratic functions, the rate of change can be given by a linear function. Okay, so let me show you an example of that. So let's say I have my x and y values, just to keep it easy. Let's say 1, 2, 3, 4. And then let's say I have 10, 12, 16, and 22. Okay, so I'm going to start by finding my average rate of change, which means that I have to find my changes in y. So I know that to get from 10 to 12, I add 2, 12 to 16, add 4, and 16 to 22, I'm going to add 6. Okay, the first time you do this process, that's going to be your average rate of change. Those changes, you see that they are not constant. You got 2, 4, and 6. They are not the same number. Your average rate of change for quadratics is going to be represented by a linear function. Okay, that just means it's not constant, but it is linear. So you want to keep going until it is constant. So that means that now I'm going to find my rate of change of my average rate of change. So to get from 2 to 4, I have to add 2, and to get from 4 to 6, I also have to add 2. So since the 2's are the same, that means that the rate of change of the average rate of change is constant, okay, which is what you want. So if you repeat the process 2 times and your rate of change of your average rate of change is constant, then that means that that function is quadratic, okay? For quadratic functions, again, the average rate of change is linear and the change in the rate of change is constant. Now I inserted a picture of what a quadratic function looks like. Just as a refresher, the shape of this graph is a parabola and it could open upward or downward, so it could also look like this. So it just depends what the function is exactly, okay? Let's go on to example 1. The table gives selected values of the function f of x. Explain why f of x is not a linear function, okay? So remember that for the average rate of change, we need to find the change in x. Sorry, I keep saying that, the change in y divided by the change in x, okay? So when you have a table, what you're going to do is figure out the differences in the values of x and then the differences in the values of y. Once you do that, all of these are going to be considered your change in x, and on the right side, they're going to be considered your change in y. So to get from 1 to 2, I have to add 1, 2 to 4, I have to add 2, and 4 to 8, I have to add 4. Okay, on the other side, I'm going to be adding 3. 4 plus 3 is 7, 7 plus 3 is 10, and 10 plus 3 is 13. Now, that's not exactly the rate of change. So what I'm going to have to do is grab all of these x values, and I'm going to put them over here, and I'm going to divide them by my changes in y so I can actually find the average rate of change. Okay, so because this first change in x was 1, I'm going to divide this change in y by 1, the second one by 2, and the third one by 4. Okay, so now let me simplify. 3 over 1 is just 3. 3 halves cannot be reduced, and neither can 3/4. Okay, now when you do this process the first time, I want you to circle your numbers and I want you to label them your average rate of change. Okay, now we know that for linear functions, your average rate of change has to be constant. I see that these numbers are not constant because they are 3 different numbers. 3, 3 halves, and 3/4 is not the same number. So for that reason, this is not a linear function. So I'm going to write f of x is not a linear function because the average rate of change is not constant. Okay, so again, if it were constant, like let's say there were all 3's, 3, 3, 3, then this would be considered a linear function, right? Because then if you do it again, your change in your rate of change would be 0. So that would qualify all the requirements for something to be a linear function. Your average rate of change has to be constant, and your change in your rate of change has to be 0. But again, this was not linear. Okay, let's go to the next example. Consider the quadratic function g of x equals x squared. Complete the table of values for g of x over the consecutive equal length input value intervals below. Then complete the table for the average rates of change of g of x for each consecutive interval of equal length input values. Okay, so the first thing I'm going to highlight is that they are giving me a quadratic function and they have let me know that it's equal to x squared. So on this first table, I'm going to set g of x equal to x squared because again, it is the same function as they gave us here. G of x is x squared. Okay, so in order to do that, I'm going to be plugging in these x values in here. So negative 3 squared is positive 9, negative 1 squared is positive 1, 1 squared is 1, 3 squared is 9, and 5 squared is 25. Okay, so we're going to find the average rate of change first, which means that we need to figure out our changes in x, and we're also going to figure out what the changes in y are. Okay, so on this side, I'm going to get the changes in x. Over here, I'm going to get the changes in y. I noticed that on the changes in x, I'm always adding 2. And to get from 9 to 1, I have to subtract 8. 1 to 1 means that I'm not adding anything. 1 to 9, I have to add 8. And 9 to 25, I have to add 16. Okay, but remember, we have not actually found the average rate of change until you grab all of your changes in x and divide them on the other side. Okay, so all of my changes in x were 2. So that's going to make this easier. I'm just going to divide all of them by 2, and then I'm going to simplify. This equals -4, 0, +4, and 8. Okay, now remember that the first time you do this process, I want you to circle your numbers, and I want you to label them the average rate of change. Okay, notice that these numbers are not constant. Okay, so remember, for a quadratic function, your average rate of change is linear. So here, the average rate of change is given by a linear function because it is not constant. Now moving on the second table, they have given us intervals and they want us to plug in the average rate of change. Okay, now we've actually already done these intervals. We already did -3 to 1, which is all this work here. From -3 to 1, our average rate of change ended up being -4. So I'm going to plug -4 there. Okay, from -1 to 1, we also did all that work, as you can see here. The average rate of change is 0, and then the same numbers for the rest of them. So we actually already did that. Now we're going to repeat the process one more time to see if it's going to give us a constant number. So you're going to find the change in the rate of change. So to get from -4 to 0, you need to add 4. 0 to 4, also add 4, and same thing from 4 to 8. Okay, now the second time you do this, I want you to circle your numbers, and you're going to label them your rate of change of your average rate of change. Okay, now you can see that 444 is the same number, so that means the rate of change of the average rate of change is constant. Okay. Now, when you're doing this moving forward, you don't have to separate this process into 2 separate tables. We could have actually just kept going from here and did +4, +4, +4, which is what we're going to do in the next few examples. So there's no need to separate the tables, although you can. And then sometimes you're only going to be given this information. Like I've seen multiple choice problems where they say the average rate of change from -3 to -1 is -4. And the average rate of change from -1 to 1 is 0. And then, so they're not giving you the y values and they're not giving you the equation. They're actually going to be starting you off here. So it is helpful to understand how this table works, although you won't use it 100% of the time. Okay. So what do you notice about the average rate of change of g of x over consecutive equal length input intervals? Well, here are the average rates of change. I noticed that these intervals are increasing at a constant rate of 4, right? Because to get from one to the next, I have to add 4. So even though this is not constant, I do know that those numbers are increasing, right? Because if I keep adding 4, I'm going to do 8 plus 4, and then keep adding 4 plus 4 plus 4 plus 4, and these numbers are going to get bigger, 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 bigger. Okay? So I can say the average rates of change of g of x over consecutive equal length input intervals. Okay, so remember, when you're given a free response question, all you're going to do is restate the question back to them. So actually everything that I've written is not even part of my answer. I have literally just restated this entire thing, the average rates of change of g of x over consecutive equal length input intervals. And then we're going to say are increasing at a constant rate of 4. Okay, so the rates of change of g of x are given by a linear function. Okay, so just to recap, the rates of change over here are increasing, so these numbers are going to get bigger and bigger and bigger because we're always adding 4. And because the average rate of change was not constant, that means the average rate of change is linear, okay, for every quadratic function. Let's move on to example 3. Selected values of various functions are given in the tables below. For each table, determine if the function could be linear, quadratic, or neither, okay? So we're going to repeat all of the steps that we've been taking, which is finding the changes in x, and then we're going to find the changes in y. So all of my x values are adding by 1. Here I add 1, plus 3, and plus 5. Remember to divide your changes in x over here so that you have the change in y over the change in x. So I'm going to divide by 1, and by 1. Okay, now that's not really going to make a difference because everything divided by 1 is whatever you started with. But I'm going to circle these and I'm going to label these my average rate of change. Now I see that those numbers are not constant, which means that they're going to be linear. Okay, now I'm going to repeat the process again. So to get from 1 to 3 and 3 to 5, I need to add 2. Okay, now that's the second time I repeat the process. I'm going to circle these. And I'm just going to write this down here because I kind of ran out of space. And I'm going to say the rate of change of the average rate of change is constant. Okay, because the 2's are the same. So that means that f of x has to be quadratic because the change, we can say because the rate of change of the average rate of change is constant. Okay, they could also say, I can say alternatively, let me see, or that's it's shorter to write than alternatively. They could say because the average rate of change is linear. They might say something like that. Okay, so one or the other. Okay, let's try this again. So we're going to find the changes in x for letter B. So I'm going to add 1 here, and then here I'm going to add 3, and then here I need to add 5. Okay, and then on the y side, I'm going to have to add 1, plus 3, and plus 5. Okay, so remember these are my changes in x, these are my changes in y. I'm going to need to divide these numbers over here so that I can actually find the average rate of change. So we got 1, 3, and 5. Now any number divided by itself is always going to be 1. So I'm going to circle those numbers and I'm going to label them my average rate of change. Now notice that the average rate of change is constant, right? That means that this table has to be linear because you did it one time. If you were to repeat the process and do it again, so from 1 to 1, I have to add 0. Okay, so then you can circle those, and then these would be, I'm going to put this down here, the rate of change of your average rate of change is 0. Okay, so I can say g of x is linear because the average rate of change is constant. Okay, I should box in my answers because it's really hard to see where they are. Let me do it in this color. Oops, I don't think that's gonna work. Okay, and then this one. Okay, so those are my final answers for A and B. So A was quadratic and then B was linear because the average rate of change is constant. Okay, last one, let's try letter C. So the same process. This is going to be the process for the entirety of the notes. You're going to first find your change in x, and then you're going to find your change in y, and then find the average rate of change. So for my changes in x, I see that I'm adding 2. And over here, I'm going to be adding 2, adding 1, and adding 0. Okay? Just like before, you're going to grab your changes in x, divide them by your changes in y. So we got divided by 2, 2, and 2. If you simplify these, you get 1, 1/2, and 0. The first time you do it, circle them and label them the average rate of change. You can see they're not constant, so we'll say that these average rates of change are linear. Okay, at which point you would repeat the process. So you would do 1 to 1/2. You're going to subtract 1/2, and 1/2 to 0, you're subtracting 1/2 again. So I'm going to circle these, and I'm going to say that the rate of change of the average rate of change is constant. Okay, which means that this table for h of x is quadratic because the rate of change of the average rate of change is constant. Now I know I'm abbreviating rate of change and average rate of change. Just know that on the real AP test, you cannot use abbreviations. So you will have to write everything out. They just want to make sure that you know what everything stands for, so you can't use abbreviations. Okay. Now we also touched on concavity a few lessons ago. There is a typo on here too. It's missing the word rates. So I want you to insert there. They should say in their rates, and then same thing for concave down. So it should say for concave up, the average rates of change over equal length input value intervals is increasing for all small length intervals. And for concave down, the average rate of change over equal length input value intervals is decreasing. Okay, so when something is concave up, it's going to look like a smiley face. We've talked about that before. We've also talked about when your slopes are changing. So notice that here, since I'm going down, this means that my rate of change is going to be negative. We talked about at the maximum or minimum, your rate of change is 0. And then when you go back up, my rate of change is going to be positive. Now, for concave up, it doesn't strictly mean that it's always positive. The word is increasing. That means it's moving as you go. As you go through the curve, your rates of change are increasing, meaning they're getting bigger, right? Because you're starting with negatives, and then your negatives get smaller and smaller and smaller until you hit 0. And then from there, you have a really small positive, medium positive, bigger positive, bigger, bigger, and bigger, bigger, and bigger positive. So as you progress through that smiley face that's concave up, your rates of change are increasing. Now for decreasing, it's going to be a similar concept. You have that concave down frown. Now when you start, your rate of change is positive. When you hit the maximum, your rate of change is 0. And after that, your rate of change becomes negative. So we say the rates of change are decreasing because as you progress through the curve, your slopes are getting smaller and smaller and smaller, right? At the beginning, you have a big positive, medium positive, little positive till you get to 0. And then a little negative, medium negative, and then big negatives, big negative, big negative, big negative. Okay? So what that means, decreasing is an action, is a movement as you progress through the frown. Your rates of change are decreasing. Okay? Let's go to the next page. For example 4, it says selected values of the functions k, m, and p are given in the tables below. For each function, determine if the function could be concave up, concave down, or neither over its domain. Okay, now the question is similar to the one we did in example 3, but the question is now saying is it concave up or down, or neither. That's also a possibility. So the process again is similar to what we've been doing. You're going to find your changes in x, changes in y, and then find your average rate of change. Okay, so for my changes in x, I see that I'm always going to be adding 0.1. And for my values, my changes in y, subtract 3, subtract 2, and then I subtract 1. Just like before, you're going to grab these numbers, you're going to divide them by your changes in y. So I'm going to divide all of these by 0.1. Now you might be asking, how do I do this without a calculator? Okay, so let's say we got the fraction negative 3 divided by 0.1. I know that 0.1 as a fraction could also be written as 1/10, right? 1/10 is 0.1. So then I can do keep, change, flip, where I keep the numerator, I change the sign to multiplication, and then I'm going to flip the bottom. So instead of 1/10, I'm going to have 10/1. Okay, and remember, all whole numbers are divided by 1. So this is really just negative 3 times 10, which is negative 30. Okay, so this is negative 30. So in reality, all we're doing is multiplying everything by 10. So negative 2 times 10 is negative 20, and negative 1 times 10 is negative 10. Okay, so just like we've been doing, you're going to circle the first ones, and you're going to label those your average rate of change. Okay, now let's repeat the process one more time. To get from negative 30 to the negative 20, I need to add 10. And from negative 20 to negative 10, I'm going to add 10. Okay, so my rate of change of my average rate of change is positive 10. I'll put this over here, rate of change of your average rate of change. Now, this is going to be a little bit different than the other one when we were talking about linear and constant. So I see that my rate of change of my average rate of change is a positive number. If my rate of change of my average rate of change is a positive number, that means that my average rate of change has to be increasing. Okay, why does it have to keep increasing? Because I'm going to keep adding 10, right? If I add 10 to negative 10, I'm going to be a 0. If I add another 10, I'm going to be 10, 20, 30, 40, 50, 60, all the way. It's going to keep getting bigger and bigger and bigger and bigger and bigger and bigger, all the way into infinity. Okay, so we can say that the average rate change is increasing because the rate of change of the average rate of change is positive. Okay, and if all of that is true, if your average, remember for average rate of change, if your average rate of change is increasing, that means you are concave up. So because this was increasing, that means this table is concave up. So we're going to say K of X is concave up because the average rate of change is increasing. Okay. Okay. Let's try letter B. So for my changes in X, just like the other side, I'm also adding 0.1. And then for my changes in Y, I can see that I'm always going to be adding 3. And those are my changes in Y that I need to divide by my changes in X, which were always 0.1. Now, if you remember, dividing by 0.1 is the same thing as multiplying by 10. So 3 times 10 is 30. And these fractions are all the same. So that means that they are all 30. And bubble them in and label them your average rate of change. Okay? And if we repeat the process, I see that I'm going to be adding 0. Okay? So that means that my rate of change of my average rate of change is 0. So if my rate of change is 0, that means that my average rate of change is constant, meaning that this graph has to be linear, right? So if we have a linear function, we're never going to have a smiley face or a frowny face because it should always be a straight line. For it to be concave up or down, it would have to have some kind of curve, and that's just not the case. okay? And when we're talking about concavity, you only have two options. It's either increasing or decreasing. There's no option for constant, okay? It's either one or the other. So if this ever happens to you, that means that this table actually is linear, which means that it's neither concave up or concave down. So we're going to say m of x is neither concave up or concave down because the average rate of change is constant. Oops. Okay. Let's try another one. So I'm going to first find my changes in x and then the changes in y. So for my changes in x, it's still the same thing. I'm adding 0.1. On the other side, I'm adding 6. And then I'm going to add 4. And then I'm going to add 2. And then I'm going to divide all of these numbers by my changes in x over here, which, just like the other two examples, they're all 0.1, which, like the other ones, we're just multiplying by 10. So 6 times 10 is 60, 40, and then 20. Okay, circle those, label them your average rate of change. Repeat the process. To get from 60 to 40, I have to subtract 20. Same thing here. Circle those, and you're going to label those your rate of change of your average rate of change. Now I see that these numbers are negative, right? Which means that my average rate of change is going to be decreasing. Because if I keep subtracting 20, minus 20 is going to get me to 0. Minus 20 again is negative 20, negative 40, negative 60, negative 80, negative 100. And those numbers are going to get smaller and smaller and smaller and smaller and smaller. Okay, so if your rate of change of your average rate of change is negative, that means your average rate of change is decreasing, which means your table or your function is concave down. So P of x is concave down because the average rate of change is decreasing. Okay, let's do some other examples. Example 5 says the average rate of change of the quadratic function p is negative 4 on the interval 0 to 2, and then negative 1 on the interval 2 to 4. What could be the rate of change from the interval 6 to 8? Okay, so what I'm going to do is create a table. Now there's not that much space, but I'm just going to zoom in here, and I'm going to create a table similar to one we saw on one of the other pages, where instead of x and y, how we always have it, because they didn't tell me x and y values, all they gave me were intervals and the numbers for some of the average rates of change. So we saw a table that had intervals on the left and they had average rates of change on the right. Okay, so the first interval was from 0 to 2, and I'm going to switch to interval notation because I'm not the biggest fan of inequality notation. So 0 to 2, they said the rate of change was negative 4. Then they said that from 2 to 4, the average rate of change was negative 1. And then they want you to figure out what is the rate of change from 6 to 8. Okay? Well, if you notice on this side, we're always adding 2, right? So from 0 to 2, we added 2. From 2 to 4, we added 2. If I add 2, that means there's 1 missing because I can't jump from 4 down to 8, right? So that means there's 1 missing here that you need to add manually, which is 4 to 6, because it needs to follow the pattern, right? 0 to 2, 2 to 4, 4 to 6, and then you have 6 to 8 because you're always adding 2. Okay, now we're trying to figure out what this number is right here. That's the question. What is the average rate of change for 6 to 8? Okay, now they did let us know that this was a quadratic function, which is important because we know that for quadratic functions, the rate of change of the average rate of change is constant. So if this first table is my average rate of change, which is supposed to be linear, if I were to repeat the process over here, and whatever numbers I get here, they should be constant because they would represent my average rate of change of my average rate of change. Okay? So we have the average rate of change linear, rate of change of the average rate of change constant. So I need to figure out what these numbers are so I can work backwards. Okay, so to get from -4 to -1, I need to add 3. Now that's all I have to go off of, but because I know for a fact that this side has to be constant, that means that all of these numbers are also going to be +3. Okay, and then from there I can go back to this column and just fill in the rest of the numbers. So again, -4 plus 3 is -1. -1 plus 3 is +2. And if I do 2 plus 3, this number would be 5. Okay? So that means that the correct answer would be C as in cat for the number 5. Okay, let's go to the next example. The function f is not explicitly given. The function g is given by g of x equals f of x plus 1 minus f of x. The function h is given by h of x equals g of x plus 1 minus g of x. If h of x equals -6 for all values of x, which of the following statements must be true? Okay, now this might be a little confusing because they're throwing out some really complicated equations for you. It looks like transformations. You're like, I don't even know what's going on. But if you take it one step at a time, it'll make a little bit more sense because we've actually talked about these concepts before. It just has never been worded this way. Okay, so I'm going to start off with the fact that h of x equals -6. Okay, so h of x is -6, which I know is a negative number, and because it's a number, it has to be constant. Why is it constant? Because there's no variable to change it, right? That's not like -6x, where if I plug in 1, 2, 3, 4, it's going to be -6, -12, -18, -24. The numbers are not changing based on what I plug into x, okay? If it were -6x, it would not be constant. But because it's just a number, that number is never going to change. There's nothing there saying, oh, if I plug this in, it's going to change. There's nothing to plug in. It's just -6, and that's it. It's a negative number, okay? So if you kind of work backwards, we can say g of x. So we know that there's 3 functions, f of x, g of x, and h of x. G of x is a function of f, and h of x is a function of g. So h of x is -6, which is a negative constant. We've heard about this before, right? Let me go back and refresh your memory. When we have a negative constant, that means that the previous thing meant that it was decreasing. Okay, so that means that g of x is decreasing. This is going to be representing your average rate of change, and the other one represents the rate of change of the rate of change. Okay, and so if all of that is true, that means that f of x has to be concave down. Okay, now that might be a little weird to understand still, so what I'm going to do is make a table, okay, just as a further example. So let's say I have x and f of x, okay, and I'll keep it simple on this side. Let's just say 1, 2, 3, 4. Now they didn't tell me what f of x was, okay, but then there's g of x, and then there's h of x. Now they told me that h of x was always -6. So I'm missing 4 numbers that I would go do this 4 usually, which would give me 3 numbers. And then if I were to do it again, I would get 2 numbers, okay? All they have told me is that h of x is -6, okay? So I'm gonna put -6, -6. From there, I can come up with any random numbers. They didn't give me any numbers, I'm gonna just make up a number. Okay, let's say I pick 12. 12 minus 6 is 6. 6 minus 6 is 0, okay? Now I'm gonna work backwards again. Let's say I pick any random number again. Let's say I pick 24. 24 plus 12 is 36. 36 plus 6 is 42. 42 plus 0 is still 42. So if we work backwards, all of this -6 is saying, again, is that the rate of change of the average rate of change is negative. And we said that if your rate of change is negative, that means that your average rate of change is decreasing. And if all of that is true, then that means that f of x is concave down. Okay? So we've done examples like this, we've just never been worded like that before. But if we go through the answer choices, let's see which one is correct. So I see that they all start with h is negative and constant, negative and constant. So let's focus on the back part. The graphs of g and f always have a negative slope. No. The graphs of g and f are concave down. Well, not g of x. F is concave down, but not g. So I'm going to eliminate b. A is also gone. And then we have, for answer choice C, it says that g is decreasing and the graph of f always has a negative slope. That's not true because even though this is a frowny face, right? We know it's concave down. Always know that half of the frowny face always goes up. So the first half of that is going to have a positive slope. So we can't say that it always has a negative slope. It only has a negative slope on the second half of the frowny face. So C cannot be the correct answer. Now D is the correct answer and it satisfies everything we've already written down. We said H is negative, check. We said G is decreasing, check. And we said F is concave down, check. Okay, so D is the correct answer there. For example 7, the table gives values of the function f for selected values of x. If the function f is linear, what is the value of f of 13? Okay, so let's start with the same process as always, which is finding your changes in x and y. To get from -3 to 3, I'm going to add 6. From 3 to 6, I need to add 3. From -10 to -2, I need to add 8. And this one I'm going to be adding 4. These are my changes in x. These are my changes in y. I'm going to be coming down, dividing this over here so I can actually find the rate of change. So we got -8/6 and, +8/6 and 4/3. Okay, so let me reduce this. 8/6 is also 4/3 and then this one is still 4/3. Okay. So remember that the first time you do this process, you're going to circle those and you're going to label it your average rate of change. Okay, remember that your average rate of change is just your slope. From algebra 1, we know that the slope is always represented by the letter m. Okay, so we're trying to figure out what is f of 13. That means that x is 13. What is the y value? That's what we're trying to figure out. Okay. For a linear function, again from algebra 1, we know the equation for any linear function is y equals mx plus b. Okay, so I know the slope is 4/3. What I don't know is the y-intercept. So what I'm going to do is I'm just going to pick any point that I want. Okay, pick any point. I'm going to pick 6 and 2 just because they're positives and it'll be easier. So I'm going to pick, let me just put examples. So I'm going to pick 6 and 2 and this is going to be my x and y that I'm going to plug into the formula. So y is 2. I know that the slope is 4/3. I'm going to plug in x, which is 6, and then I'm trying to figure out what b is. Okay, so let me color coordinate some stuff. So 6, which is x, is going here. The 2 that is y is going here. And then the m that is 4/3 is from this part over here. Okay, so we're doing this because you can't have two unknown variables. I can't be solving for y and at the same time I don't know what b is. Okay, so this has to be a two-step process. All right, so in this process, I'm solving for b. And then in the next step, I'm going to solve for y. Okay, so 6, I can write that as over 1 just to make multiplication a little bit easier. So 4 times 6 is 24, 3 times 1 is 3, and then we got plus b. I know that 24 over 3 is 8. To get b by itself, I'm going to have to subtract 8 on both sides. I know that 2 minus 8 is negative 6. Okay, so that means that my y-intercept is negative 6. So now on to the second step. Now I'm going to plug in x equals 13, which was the original problem. What is f of 13? Okay, so the function was y equals 4/3 x, and then the y-intercept that we found was negative 6. Okay, so now I'm going to be plugging in 13. So we got y is 4/3 over 13 minus 6. Let me color coordinate here. So this 13 is going into this x, which is right here. Again, to multiply easier, you can put that over 1. So 4 times 13 is 52 over 3. And then this is minus 6. Now you can't subtract unless you got the same denominator. So I'm going to put 6 over 1. And then to get the same denominator, because this one is 3, I'm just going to multiply this whole fraction by 3. So 52 over 3 is actually going to stay the same. And then 6 times 3, which is 18, and 3 times 1 is 3. Now that they both have a denominator of 3, I can just subtract the numerator. So 52 minus 18 is 34. And the denominators, which are common, they're the same, stays the same as well. So the y value is 34 over 3, which is answer D as in dog. Okay, so that was a two-step process, well, kind of a three-step process. 1, find the slope. 2, find the y-intercept. 3, plug in the x and get y. Okay. Example 8. The function f is defined for all real values of x. For a constant a, the average rate of change of f from x equals a to x equals a plus 1 is given by the expression 2a plus 1. Which of the following statements is true? Okay, so let's see what I have. They told me that the average rate of change is given by the expression 2a plus 1. That kind of looks a lot like what we just did, isn't it? 2a plus 1 is a linear function. There's no exponents, no absolute value, no square roots, nothing like that that would make it any other type of function except linear. So already, not that many words, but they did tell me that the average rate of change is linear. What type of function has the average rate of change is linear? A quadratic function. We talked about this as well earlier. Okay, so if I know that the average rate of change is linear, which is 2a plus 1, then I also know that my slope is 2, which means that the slope is positive. So I know that the slope is positive. If my slope is positive, then that means that the rate of change is increasing. We talked about this on a few pages ago. So if the rate of change is increasing, then that means that the graph is concave up. Okay, so let me give you an example, because I know that probably doesn't make any sense just like that. So let's say I have values for a. They gave me a. They said that x was a, right? So well, yeah, I'll just put a there because they didn't say 2x plus 1, they said 2a plus 1. So let's say that the x variable is a, which they actually say that already. So a is x, and then the equation was 2a plus 1. Okay, But remember that they said 2a plus 1 represents the average rate of change, not the function. They said the average rate of change is given by the expression 2a plus 1. Okay, so that means that if I were to repeat the process, right? I don't know. Let me just put some numbers. That means this side would have my rate of change of my average rate of change. Okay? Now let's say I make up some numbers. I'll keep it easy. I'll just do 1, 2, 3, 4. Okay? If I plug these numbers in there, I would have 2 plus 1, which is 3. 2 times 2 is 4, and 4 plus 1 is 5. 3 times 2 is 6, plus 1 is 7. 4 times 2 is 8, plus 1 would be 9. Okay? And if I were to repeat this, that means that my rate of change is always going up by 2. So that means that the rate of change of the rate of change is positive, which means that your average rate of change is increasing, right? Because I could keep adding to 9, 11, 13, 15, 17, 19, 21, etc., etc., and it's going to get bigger and bigger and bigger, which means that whatever this graph is, the original graph, which is f, that means that function f has to be concave up because the rate of change is increasing, because the rate of change of the rate of change is positive. Okay, so let's see which one makes sense. The average rate of change is positive. Well, we said that the average rate of change is increasing, not that the average rate of change is positive. So we're going to eliminate that one. The average rate of change of the over consecutive equal length input value intervals is positive. Again, we're going to eliminate that one. The average rate of change is increasing at a constant rate. So the graph could be a line with a positive slope. Well, if remember you have that the rate of change is linear and your rate of change is constant, then that means that the graph has to be quadratic. So in actuality, C could not be the answer because they said it was going to be a line, which means this is for a linear function. Now, if you look at D, it says that the average rates of change are increasing, check, at a constant rate, check. So the parabola, we know that a parabola is a quadratic. So that means that D as in dog is the correct answer. For example 9, an object is moving in a straight line from a starting point. The distance in meters from the starting point at selected times in seconds is given in the table. If the pattern is consistent, which of the following statements about the rate of change of the rates of change of distance over time is true? Again, repeat the process. All of the steps are always going to be the same for these types of problem. You're going to find your changes in x and your changes in y. Plus 2, plus 3, plus 5. Over here, plus 8, plus 12, plus 20. Grab these numbers, divide them over here so that you have the change in y divided by the change in x. So I have divided by 2, divided by 3, and divided by 5. If I simplify these, I get 4, 4, and 4. Okay, I'm going to be circling these. Remember, the first time you do it, you're going to label it your average rate of change. If I do this process again, from 4 to 4, I'm going to be adding 0. It's kind of hard to see it. Plus 0, plus 0. These here are my rate of change of the average rate of change, which is, of course, 0. Okay, so let's see. Answer choice A says the rate of change of the rate of change is 0. We got that. Okay, so let's keep that as a contender. The rate of change of the rates of change is 0. We got that. The rate of change of the rate of change is 4. No. That's false. If all it had said was the rate of change is 4, the rate of change is in fact 4, but they said the rate of change of the rate of change. And for that same reason, we're also going to eliminate D because they said the rate of change of the rate of change is 4. Okay, so now we are between A and B. Now, if you read very, very carefully, you'll notice that the only difference is that this one says 0 meters per second and this one says 0 meters per second per second. Now, since we had to find the change 2 times, we did it once here and a second time here. That means that the units are going to kind of duplicate, so it'll be double. So the rate of change of the rate of change is 0 meters per second per second. So the correct answer is B as in boy. Okay, we are down to the last problem, which is example 10. The table gives values of a function f for selected values of x. Which of the following conclusions with reason is consistent with the data in the table? Okay, let's find our changes in x and our changes in y. So to get over here, I'm going to add 1, add 1, add 1. Down here, I'm going to subtract 3, subtract 1, and then add 1. I'm going to bring this, and I'm going to divide them over here. Now, since they're all 1, it's not really going to have much of a difference. The numbers are going to stay the same, which is -3. Let me keep the same number. Sorry, the same color, -3, -1, and +1. So these here are my average rates of change. Now if I do it again, to get from these numbers, I'm going to have to add 2. Okay, so this is my rate of change of the average rate of change. And as you can see, these numbers are constant, while the average rate of change is linear. Okay, which means that this whole table is quadratic, right? So that means f of x is quadratic. So let's see. F could be linear. Nope, we just said it was quadratic. F could be linear. Nope. So C and D are the only ones that say F could be quadratic. Now let's see what the differences are. Because the rates of change over consecutive equal length intervals in the table can be described by, so now we're looking at 2 different equations, either y is 2x or y equals 2x plus 1. Okay, now that 2x is actually coming from the 2 that's over here. So this is the slope, which is 2, that they're talking about over here. For 2 and 2, this is the slope. This is the rate of change of the average rate of change. Okay, so that's where that number is coming from. Now let's say that we look back at the graph, and then I know that in a, remember that for quadratic functions, your average rate of change is linear. So that means that this has to be of the format y equals mx plus b, which again, this is the slope, and this is the y-intercept. Okay, so let's see. So the correct answer here is D as in dog. So that y-intercept, you can see it on the table, which is right here. That's your y-intercept whenever your x value is 0. So whenever you have 0 as an x value, that's your y-intercept. So that means that for B, it has to be plus 1, which is in D as in dog. Okay, and that is today's lesson. I hope it makes sense. Leave me a comment if you have any questions, and I'll see you guys in the next video. Bye.